Okay, so we're going to start with this page, the definitions. So the first one is theoretical probability. So theoretical probability just means that's the likeness of an event happening based on all the possible outcomes. And you can kind of shorten this if you need to, but theoretically just the likeness of an event happening based on all possible outcomes. So remember when we talked about it before, when we first learned it, kind of like in a perfect world, what should happen. But sometimes, like when we played that dice game, the decimal dice game, some of you were freaks and you guys rolled doubles every single time you got it. Was that theoretically what's supposed to happen? No, that's kind of unlikely for you to roll doubles every single time that you get the dice. But theoretically, what's supposed to happen based on all the possible outcomes. Experimental, the ratio, you can go ahead, Lauren. The ratio of the amount of times an event occurred to the total number of times of trials or times it's done. So ratio, so we've got a fraction, so amount of times over total. And the definitions will make more sense to us when we go back and look at example problems. Right now it doesn't really mean much when you say it like that. Independent events and dependent events. So those questions you get where they'll say, Sally picked a marble out of the bag and she put it back in the bag. She pulled one out and then she replaced it. And compared to those that are like, she pulled one out and she didn't replace it in the bag. That means that's your independent and dependent events. So independent, the outcome of one event does not affect another event. So that would be a question like, what's the probability that Katie pulled a red marble out of the bag, replaced it, and then Jaden pulled a blue marble out of the bag? So we put all those marbles back in, so when he went to grab the new marble, there was the same amount as when Katie grabbed it. So it didn't really make a difference. So it didn't affect the other event. As opposed to dependent, where the outcome of an event does affect the outcome of another event. So that would be Athena grabs a red marble out of the bag, and then she says she wants to keep it. So then Caitlin goes and she pulls a blue marble out of the bag. Well, now there's less marbles overall because Athena kept the first one.
Wait, what does it say after of?
After the outcome of an event does affect the outcome of another event.
No, like after the first of. The outcome
Of an event. You all good? The outcome does affect the outcome of another event. And you can kind kind of shorten this or put it in your own words as long as you understand it. Sorry. Now. Okay. Yeah. Okay. So then what I want us to do is flip on over. Just flip that flap right over where it says possible combinations. So we'll make a list and then we'll look at tree diagram for that. So possible combinations, list all possible combinations of tossing a coin. So how many sides are on a coin?
2.
On a coin, 2. Heads and tails, right? Rolling a dice, how many sides are on a dice?
6.
6. And spinning an equal section color spinner, red and blue. So that's just 2 of those. So we want to make a list. So we have to make sure every single option is there. So what we could start with is we can start with heads. So say I land on heads, I land on a number 1, and I land on red. So then my second combination could be heads,
2.
1, and blue, because I have to use all my possible combinations.
Head 2 and red.
But we want to use all the combinations for the coin too. So tails 1 red, tails 1 blue. So that's all my combinations with, yes? That's all my combinations with the number 1. So then we can go through and do the exact same thing with 2. So I roll heads, land on a 2, and I land on red. Heads, land on 2 and blue. Tails 2 red, tails 2 blue. So if you kind of are getting the gist of it, we can go ahead and I'll be filling them in up here. So you try to fill them in too. Because you want to hit heads for each one, tails for each one, and get both of those colors in there. All the way to 6, yeah. So the next one, we could land on heads and 3 now in red. Heads 3 in blue, tails 3 in red, and tails 3 in blue. Same thing with 4. Okay, that's a lot. So you're just listing every single possibility. So the first time I go, I could land on heads, I could land on 1, I could land on red. The second time, I could land on heads, I could land on 1, I could land on blue. This isn't saying exactly what's going to happen. This is just saying what are every single possibility, what's every combination that we could make.
I'm not sure what happened. That's all you have to do. I wrote a roller coaster.
Oh, that's all you gotta do. And so we should end up with 1, 2, 3, 4, 5, 6, 7, 8. 25 possible combinations. Then your tree diagram, if you were to look at the tree diagram of this, it would be pretty similar and you should end up with the same number of combinations. But if we start with heads and we start with tails, then if I land on heads, then I've got 6 sides for the dice. 1, 2, 3, 4, 5, 6. Same thing with tails. I could land on tails and I could land on any number of those dice, any side of that dice. Then from there, just a different representation of this. If I land on a 1, then I could land on a red or a blue. So just 2 different ways that you could possibly see this on your test of every combination.